Hi everybody, it's Keith again with Bob CNC, and as always I'm with the Bob of the CNC. This is Shop Talk, and we're talking about the things you need to be aware of.
And with Keith of the...
Oh, you don't even care about me, I know.
We're
talking about the things that you need to be concerned about when you're buying a CNC.
Right here.
Oh yeah, I felt that too. You've hit me like that a couple of times.
Yeah. I hit you again. What are we talking about?
Well, you're building, let's say you don't buy a kit.
Yeah.
And you're going to build your own CNC.
I've always done that.
You have always done that. That's how we ended up where we are.
Yeah.
Okay. So,
Toys. Yeah.
Toys. Yeah. And electronic stuff.
Yes.
So how do you hook it up? I mean, I've got the machine made. I've got the router mounted.
Yeah.
And nothing moves. I can turn the router on and off.
Or you just got a really good deal on eBay. This great big CNC machine for $400, and yet you don't know how to hook it up.
Yeah. Oh yeah. So how do you make it work, Bob?
Yeah. Well, I don't know if I can go into the depths of that here, but maybe we can cover the generalities. Is that a word? Generalities?
Generalities?
Probably not. Oh.
It is. Okay. Generalities.
Okay. Good. All right. So when most stepper motor systems or servo motor systems in the hobby world are going to be step direction driven. So they have a step signal which makes it go one step. For stepper motors or servo motors, it still goes only so far distance, and then it's going to have a direction, which means if it's one direction, it'll go clockwise, the other counterclockwise. So you're going to see on your controller, there's a step direction signal, or it'll say pull direction, but it'll be something to do with step and direction. So you're going to have a driver, and you're going to connect those to the step direction signals, and then you're going to connect the power. And there's some other ones, maybe enable or some other things, but those are going to be the main two. So now what happens is every time your computer sends that signal, step direction is going to move. But it's only going to move one step, and it doesn't know how it's configured, so it doesn't know how far that actually moved. So a belt system will be different than a ball screw or a lead screw. So you have to know the resolution of your system so that you can set that parameters. So for instance, our Evolution series, we move in the X and the Y 80 steps per every millimeter. So we step 80 times every millimeter, right? So we have to set that parameter in there. So that's one.
Okay.
That's, how far it moves every time you hit a step. So that's going to be your, steps per millimeter, steps per inches. Okay, so you can figure this out iteratively, like, put a number in there, push, 1 inch, measure how far, if it moved over, change it until you get in. But it's actually better to do it mathematically to know how far your lead screw turns every time it goes around.
And you're going to get that from the manufacturer.
Where you made the part. But if you bought something off of eBay or the new Facebook Marketplace and you didn't have that, then yeah, you would have to figure that out. So you turn it around once and say, yeah, that looks like about 1/10 of an inch, so I'll do that. And then you can iteratively do it or not. So the other thing that you're going to have to know is how fast can it go. So there's a maximum steps per minute, right? And then there's the acceleration. How fast is it going to change in velocity? So, if it's really slow, you'll hear it ramp up and then ramp down. If it's too fast, it may not be able to handle the inertia of the system, so it may miss steps. So you're going to have to set those. So honestly, you may not need to worry about this if you buy it like from Bob CNC, it's already set up, or if you bought it from another manufacturer, they're going to have that set up for you. But if you're building your own, or if you just don't like the way it homes so slow and I ain't got all second, you could actually increase that a little bit, right, so that it homes faster, or maybe it homes too fast for you. You can go in and change those values so it homes slower. Or you think that,
Where are you changing these values?
Well, it's different on different machines. So it's either in your software, like if you use the Linux CNC or the Mach software, they're really popular for the older systems, or actually I know Mach is tied up with Ethernet or a USB connection. Or with the firmware that we use Gerbil firmware 1.1. And it's actually, we used Universal G-Code Sender. So you can actually change the firmware on the controller using the universal G-code sender. Those are the $ values.
Right.
And for ours, all of our values are listed in the manual, and you can also do a reset. But yeah, if you want to try those different ones, you can try to change the acceleration a little bit slower, a little bit faster. I will say that we've done a lot of testing, and we've tried to set it up to where it's optimal for our machine. So I wouldn't go too far out of those bounds, and I would imagine that's true with most manufacturers. But just be aware that if you have a machine, all of those values are important on, steps per revolution, how much speed you have, the acceleration that you have, the direction that you have. So they're there for you, and you can change them to modify your machine to do whatever you want it to do.
Now, you're looking for a machine.
Mm-hmm.
You're not building one.
Right?
And we've used the term resolution.
Mm-hmm.
And I'm pretty sure everybody listening kind of got that in context. But what does that mean when I'm comparing this machine with that machine? Like we advertise our resolution is 2,000th of an inch. What does that mean practically?
Well, there's two different ways that you can look at this. First of all, if you have a ball screw, probably the optimal, if it's a good ball screw, right? You have a really precision, you can, get into the tens of thousands, right? However, they're typically slow. Really accurate, really slow. Now you can get into the belt system, right? Really fast, not as accurate. So you have to ask yourself. I've read on forums where people are trying to do microns. If you're a woodworker, you have no need for microns. I'm telling you, the wood compresses as the bit's going through more than microns, and it bounces back. So, as a matter of fact, in woodworking, if you've tried to make a joint, you know that you have to leave like 10,000ths, which is like huge, right, for a machinist, even to get your joints to fit,
right,
because of the way that wood reacts. So, pick your poison. You want a slower machine, but you need accurate, or maybe not poison. What are you doing with it? If you're manufacturing parts for NASA, you don't want a hobby machine. And if you're making plaques...
Not, sir, with my new business model. Well, I was going to try.
Oh, were you?
Well, I thought we could...
You have learned a lot about G-code.
Not much.
Yeah.
Go ahead, Bob. I'm sorry.
Anyway.
I interrupted.
Yeah, not a problem. It really just, if you're making metal parts, you're going to want a ball screw, even if you're doing wood parts, but, you really want it to be really a cool machine. A lot of people like the ball screws. Honestly, I'm in love, everybody should know this, I'm in love with the Bell Everman design. It's a servo drive that you can look up on the internet, but it gets rid of the belt stretch, and so it's fast, and it's really pretty accurate. So really like that design. So,
well, guys, if you have any questions about things you're looking at when you're shopping for a CNC, you don't want a sales pitch. You like an honest opinion. You can get a hold of us at the help desk at bobcnc.com. We'll do everything we can to help you. Our biggest concern is we want you in the right machine that works the best for you, so that you can accomplish everything that you want to do with that thing.
absolutely.
So till next time, we'll see you guys.